Guys, turn on your Teams and anyway, use Teams a lot because I'll be communicating to you mostly by Teams. Did you see the message we posted as well?
Yeah. Did you?
No. Use Teams at least for this semester. You all have Teams, right? Right. Yeah? Where are the rest?
Turn down this one.
Could I leave my remote?
Okay, so let's get started. So basically I posted two messages. One was, feel free to post questions on Teams and I will get to them. I look at, my messages quite frequently, email, Teams, etc. So this is also valid next week when you have exams apparently, but if you get to thinking about the assessment exercise and you have a question, feel free. Sometimes coding related issues are better explained just talking. So Teams has the feature where we can connect through audio rather than typing out something and then you understand something else and then you give a response and then I try to clarify. It's much easier to sort it out orally. Okay, so yeah, the second thing I posted was I said if you can get it installed on your own computer, you will be in a much better position because you have the software, you don't have to come here and you'll be able to work on it whenever you find time. So think about that. Now, a word about yesterday's problems. So to summarize, there were two problems. One was mine, when I was running the program that I'm about to run, and the other one was your tab completion. You are not able to use the service call to move the robot to any location, right? Now, we don't know why that is happening because my students back in the US use exactly your setup and it works. So it's one of those mysteries, I told you the open source community is not perfect, but it's probably, we can't solve that, but you're not going to be working on the Ubuntu side. Most of the time you're going to be on the MATLAB side. So hopefully when I show you the MATLAB program, which I already posted, the circle program, and if that works for you, it means that you can issue commands from MATLAB. You don't have to use that filling out the forms, version. That helps, to be able to do it from the command line is a nice support tool, but you don't need that. So two things bother me about that. The fact that the command, no part of the command is recognized. You can't even tab the first parts over. And then if you're willing to put the fields in a compressed manner, like here, see here, we need to know what is the order of the parameters, and we haven't been able to find a document to say how do you put in the frame of reference and the name of the robot. So, as I said, you don't have to be on the Ubuntu side to do those things. Okay, now the second problem that occurred was, remember the robot was going to a spin when I tried to use Ubuntu terminal command to run it in a circle of radius 2 meters. Now, I went back to my, I was literally not thinking of anything else till the moment I got back to my room and tried the same program, and it works there. So you tell me what's going on. So the only explanation I came up with is, see, numbers are being posted to the same topic, right? I want to be in command. Now, maybe there was a teleop window open and it's also providing inputs. Remember we use the teleop window? So if you don't stop the robot or stop publishing, what happens is it's like multiple people putting stuff on the bulletin board. So back in the US, we deal with robots that are like 100 kilograms and you can't carry them. So we have a joystick to move them around. That is also publishing to the topic. If you use a joystick, you're publishing to the same topic. So if you want to autonomously drive it, then you got to stop publishing from the joystick, right? Otherwise there's a conflict. It's like two drivers for the same car. So something like that was going on, I suspect. Now everything is shut down except this. And I just tested it worked, but I bet you when I test it in front of you, it won't work. I hope not. So let me reset the word so it comes back. And then I need to make this small. I do not want it to be this big. What happened to my... It's okay. So you see what happened here? I had to stop it with a 000 command. Remember I told you about this? That it does not have the so-called watchdog timer, a safety feature. So it will go on, even if you stop publishing the other command, it will go on and on. So you have to put a 0 now to override that. So that's what I did here. So let me go back to the command before that. You see here? It's 0.3 forward velocity. Don't give any Y or Z velocity because it doesn't have any meaning for this particular robot. It's not a drone. And then you give a rotation rate about the Z-axis of 0.15 radians per second. So 0.3 by 0.15 is 2 meters. And that's what you see there. Each square is 1 meter by 1 meter. So hopefully it does not fail here. Yes. So it will top out at 2 meters and then it will go 4 meters on the other side because we started at the origin. And then it will keep on going. So you can do that from MATLAB too. I just wanted to show you that it's also possible to do it from the ROS level. I also put up a document on how to use the mouse. No, you all know how to use the mouse. How to use the mouse for zooming in, zooming out, panning. It's very useful. This trackpad doesn't work very well for that. So let me go with the other command, which is 0 velocities all the way and stop it, and it stops. So try this out. Even those things that you could not try out here because of some problem, that's why it's nice to have the software on your computer. You can try it out, all the missing stuff in the 2 documents I posted. Okay, now, the other thing I want to show you before we move to the MATLAB code is to bring RViz in. Hopefully you can follow this part. I think I'm going to go, when I go home, I'm going to fill an entire wall with a display. Okay, you see that add button was missing? And that's because of when you size it a certain way, it disappears. It tries to say, okay, I can't show you everything, so I lose the add button. So now, hopefully, I can, I guess I can't do that.
Shall I try changing the
Yeah,
resolution?
yeah, sure.
This is what?
Yeah, except that I don't know why I can't pull this in.
Oh, that's too much.
Yeah, I think we'll manage because I'll minimize it the moment I'm done. I'll flip to the gazebo screen. I mean, just like
This time, this is the system is too bad.
Yeah.
Stretches things out. Does that help?
So long as I can see the add button because it disappears where it is. So long as it's there, it's okay. I think we don't need this. This is fine. Okay, huh? Oh, again, this is too much.
Try zooming out.
Yeah.
Yeah, that is about.
No, I can manage if we go back to the old one. Yeah, it's good. That is good. Okay, so gazebo is running, right? It's a process. It can't be interrupted. And here's the gazebo icon and harvest icon. So you can get to gazebo and harvest. So what we're going to do is so harvest is like a spy on gazebo. Harvest is not the same as gazebo. Gazebo is a simulator. That's the substitute for the real world. Harvest collects all the sensor data and based on your choice, you can display it here or we can choose not to. So the first thing is it's defaulting to a map, the frame of a map as the fixed frame reference. But we have not loaded a map and that's why you get this red thing here because it says unknown frame map because we have not loaded a map. So therefore, you need to flip this to ODOM. I'll tell you in a second what ODOM is. And you can see the red goes away. So you can't ignore the reds. Red is telling you that something is wrong. You can't just go past it. When launching gazebo, you see red, you have to stop and figure out what it is saying. You can't ignore it. So a fixed frame, right? I told you yesterday, there can be many fixed frames, but there can be only one word frame. Word frame is fixed frame, but there can be many other fixed frames. Now, ODOM, so imagine the robot, well, don't imagine it because the robot is sitting at 0, 0, 0. So the robot has a frame of reference. And so the ODOM frame is the frame with respect to which the ODOM's motion is measured. So typically we use / ODOM as the fixed frame. Now, if you do this, then when the robot moves, everything else will be static. Obstacles should be stationary. They can't be moving but sometimes you may want to get the robot's perspective. So then you can change the fixed frame to the robot frame. There are many robot frames. So you see here, all the choices here, all these are robot frames. This is basically the wheel left leg. So if you choose that, it's going to make that the frame of reference. The world will appear very strange because it's like you're sitting on the wheel and it'll show you what the entire world looks like. Now you don't really want that, but it might be nice to use the base footprint of the robot because then it's like you're sitting on the robot with the camera. And so that's like you're moving around on a bike or whatever and you're looking at the world. So everything, the world will appear to be moving, but it's not really moving, right? It's because the robot frame is now considered the frame of reference. So everything is relative. So we choose ODOM because we don't want the world to move right now. And then the next thing we're going to do is we're going to add two things. All this is in the two documents I posted yesterday. So that's the fallback. You don't have to say, oh, I forgot what he said, or did he say this or that, because it's all there in the two documents. So you add the robot model. See, right now the whole thing is empty. So you have to add the robot to it. And one thing I forgot to do is I don't like this black background. And so I changed it. Oh, today it's working. A little bit better, maybe it could be lighter. Maybe this. Yeah. Okay, now you can see the robot, right? Now, don't be puzzled. This is not aligned to the gazebo frame, but this can be rotated. I don't know why, I told you gazebo was part of Ross and then they went away on their own. So they haven't really synchronized it. The default view is different, and you can use your mouse and turn the whole thing around so that it aligns with gazebo. So right now it's misaligned. So we added the robot model, and then we can add the LiDAR, the laser scan. The LiDAR is it's also called laser scan. So you add this topic. So remember I told you that Orvis is a spy. We are saying we want this specific piece of information. We want to know what's going on in gazebo with respect to the laser scan. So we added it, right? We don't see anything. Remember, it was the empty world. So the LiDAR is not hitting anything. The LiDAR rays are going off into infinity. There's no return. So we're going to make the world non-empty. So for that, I go back here, and what I'm going to do is, so again, because the screen is not fully sized, it has dropped some icons here. So let's see whether we can see the cylindrical object right there. Okay, this will do. The cylinder is right here somewhere, but that will do. Let's put it, I'm going to put it there. And then I'm going to reset the world because I want the robot to be back at the origin. So now it should be able to see the cube. But we haven't done everything we need to. The laser scan. The topic has not been chosen. So it is the scan topic. If you put Ross topic list, you'll see /scan as a topic in the list. And I'm telling you, because I have experience, that this is the name for the laser topic. Just like odom was for odometry, so you have to just accept it from me. So put scan. And then one other thing I like to do is, I like to make this marker size a little bit bigger. Maybe 2.5. And it does show up. Did you all get this? Where did you get stuck?
When I added robot model, it still comes in red color.
The robot is in red or?
So left page that says robot model. That is red color.
Oh, you're getting those transform errors? Yeah. So there is that patch, I put it on Teams. You have to add it to, yeah. I think the patch has not got it into the launch file, yeah. No, into the launch file. There is some transformations that are not being published. I put it on Teams, yeah. So your launch file is missing some code, and I posted yesterday on Teams.
Yeah.
So here's the relevant information there. Here, 5 patches, you see? Now, here's what you can do. This is the easiest fix. You remove the launch file, remember empty world launch? You remove it. Now, that's not easy because I think you need permissions, but you know how to do that, right? With a sudo. So you remove it. Then you take this file, and for that also you might need, you copy it in. For that also you need sudo. So that is the best way of doing it. If not, if you want to work with whatever you have, you can use an editor, but you'll have to use sudo to edit it. So the patch itself is here. Insert these lines in the original package. So you can put it right at the bottom, but you need sudo privileges. Or you can replace the empty world launch file with the one I've uploaded. But that's going to take a little bit longer. I think if you get sudo editing privileges, then you can insert these lines in the original package. It's 2 lines, that is just a comment. So in fact, I did this a couple of days ago here because I have a new computer, and again the patches I did not transfer over. So what you need to do is first you need to download my file from the Teams folder, not the patch, the whole thing, into your downloads folder. Then you go there and say sudo copy. After you've deleted the original, you say sudo copy into the same place. And then do a cat can make again. Cat can make is like a compilation. It may not be needed, but I just do it. Right, yeah, because it doesn't know, yeah, right. So that's one way, and the other way is just to cut these lines and push it in to your launch file, right at the bottom. Maybe, yeah, right. But let me show you. The full file, this is just a patches. The full file looks like this. So how will I open it? It's a text file. No, one.
Yeah, you know, that's the text file.
Okay. Will it open? Open in there. Is it opening? Open this one opening. Preview not available. And download it. Right, download it and show it. I'm going to try and show you the file. Yeah, here. So you see here, this is the easy method. You cut and paste from the patch and just put it here, right at the end of your existing turtlebot3_empty_world.launch. Just add these lines here. Not after the launch. Launch is the end, from launch to launch, it looks at, the computer looks at. So you need to create some space here, hit some enter, line feed, and then push it in here. So you have this in Teams, you can open it yourself and you can actually copy from here if you want. You don't have to copy that. I have another file with just the patch. You can just copy it from here, the same thing. Okay, I am going to continue because I want to get to the MATLAB program also. So all of this is going to work because that's why I created the two documents for you, so that you have that as a backup. So let me just finish up this part by pointing out that that was what I wanted to show you. I brought how come it's not showing the entire queue? So first of all, the LiDAR is only scanning on a plane. So if I move the LiDAR up to greater than your height, it's not going to pick up anything. We have 3D LiDARs. This is not a 3D LiDAR. A 3D LiDAR, it won't miss anything, right? But it cannot see behind objects. So from where the robot is, at the origin, it can only see this part of one side and that part of not. So it's just cutting it at the level of the LiDAR. It's cutting the object. So if you have a very young baby and you have a 2D LiDAR, then the baby could be run over. Now I can actually move. I can go here and move I have to move it using that. We'll put it here and let's see what happens. See? It only sees one side now, right? Now, by the way, I know I mentioned this, but you're a little bit confused. Why is the obstacle in this direction and in gazebo it's in that direction? It's because I told you this is not aligned with the gazebo orientation. You can actually, it's a different mouse button here. See? You see here? I can turn this around and now it looks exactly like the gazebo screen, doesn't it? So you have to do that each time because they have not, the default view in RViz is not the same as gazebo. One last thing I want to say before I move to the MATLAB program. So if you don't like this view, there are some standard views available. There is a bird's eye view. So a bird's eye view it's like looking down from the ceiling. And there is a side view. So they have 6 standard views for you. You can go side this way, side this way, side this way, side this way, top and bottom. But typically I like an angle, right? Now why am I saying all this? Because in the homework exercise, assessment exercise, you're going to shoot a Kazam screen record. And you can pick a nice view. You don't want to be so far away that the robot looks like a dot. So Kazam is an application in Ubuntu, K-A-Z-A-M. It's very easy to use. People of your age will be able to figure it out much faster than somebody like me. So you can figure it out, and once your algorithm is ready, you can submit. All that, the details of what you need to submit will be in the problem statement. Don't worry. But you can just submit that, to show that everything is working. Now we'll get to the homework. Probably won't have time this morning, but in the afternoon. But I want to actually show you the MATLAB program. So what I'm going to do is, I don't think I need RViz anymore. So I'm going to go back to the RViz screen. Is it this one or the other one? this looks like always. If I see the whole thing, I can tell, but I'll take a chance and kill this. Yeah, it is always. But the screen should disappear. Come on, come on. No, maybe I killed gazebo. Yeah, I think I killed gazebo. That's okay. I'll pay everything and start. We'll kill this also. Okay. Alright, so first thing is pre-launch gazebo. Yeah, there it is. You are launched. Oh. So I'm going to bring up the MATLAB program now. And right now, I would rather show you the MATLAB program, so I'm going to move this over. Okay, MATLAB is loading up. Now, we may not be able to get through all of this, but because of that, I don't want to speed up. Because, you know, for you to do the homework assignment with the least amount of effort, this discussion is very important. So I don't want to speed up. If you don't finish, we'll continue in the afternoon. But let's start from the beginning and work our way down. Okay, now. So this is always needed in a MATLAB program. You know why? Because if you've previously run a program, maybe a different course, and the variables are sitting here, and now you're working on a new course, but you're using some variables that appear to be the same. It's going to grab numbers from the leftover variables. Did you know that? So MATLAB, that's why it's called an interactive, script-based language. Because if you leave stuff there, it's like you haven't cleaned up. It sees a variable that you're using in this program, it's going to go get it. It doesn't care whether it's from a previous program. So always you do these three things. This is closing all files, this is clearing the screen, you just do it blindly. Okay, then ROS shutdown. So remember I told you that most ROS programs are eternal. They go on, the robot keeps on doing something. Maybe it's going around the perimeter of a wall. So how will you stop it? You hit a Control C, right? That doesn't shut down ROS. And remember in MATLAB, when you run the same program again, whatever was not cleaned up is left there, right? So therefore, in order to make sure that you did not do a Control C to stop the program, you do another ROS shutdown here. If it's already shut down, it will say it's not running. It's not a problem, right? You're trying to shut it down twice, it's no problem. So you just put it in there. Whether it executes or not doesn't matter, because you want to make sure that ROS is not running. Because you're going to start ROS again. Right here, you're going to start ROS. So a lot of comments, but the key lines of code are this. You have to get the IP address. In my case, it's static. In your case, it may change. So you have to figure out ifconfig. Grab that. Okay, yours is also static, I heard. But on your home computers, maybe it's not. But watch out. If it doesn't work, it could be that the IP address is not matching your current situation. And then you start ROS code. This is the command that starts ROS code. Okay, then Where? Oh, too sensitive mouse. Alright, now remember, we have publishers and subscribers. You cannot talk to the raw side from MATLAB unless you identify the data you're interested in working with. So, this is a publisher. You're going to publish velocity commands, right? So, this is the ROS function that identifies that this is a, this is the topic message structure. So you're accepting that from me because it's all there in the ROS.org. So this is the message structure, just copy it blindly, and this is the topic name, / command cmd_well. Is that okay? And typically it's normal practice to pause a little bit because it takes time for it to complete. So this is my name. Don't think that it's part of, a rule. You can call it anything you want. You can call it Rajnikant if you want. Just joking, but you know what I mean. You give it a name that makes sense to you. Later you look at it and say, oh yeah, it's publishing velocities. Now, I just make a note here that you can publish, if you know what this topic is for some other robot, even a huge robot, you can do the same thing for that robot. This program works for anything, provided you get the right topic. Okay, then you actually need only one subscriber, but I'll tell you why I have time, right? Yeah. How many minutes? 15 minutes. Okay, yeah, we can get through about half of the program. So, I also need a subscriber for the odometry. So, this is the odom topic. No need for message structure here, unlike there. So, this is the odom topic, and you have to use raw subscriber, and I call it sub-odom. I'm subscribing to odom. Now, I'm also subscribing to something called model state. This is very unique to the simulator and not the real world. So, because it's a simulator, right? Remember I told you that the wheels may slip and so on, so odometry will not be able to precisely say where the robot is. Well, that's in the real world. In a simulator, you absolutely know where the robot is actually there. And that turns out to be a very useful feature, because if you are trying to develop a new algorithm and you're trying to guess at where the robot is, some localization, some fancy new localization method, you can always compare with where the robot really is in a simulator. You can't do it in the real world. Nobody knows the exact location of a robot in the real world. Did you get that? You think, why is he saying that? The robot is right here. Right here is not precise localization, right? When we drive a car, we don't care about precisely where the car is. But if somebody asks you, where is your car precisely, you will not be able to say. So, only in a simulator this is available. Model state is the true state of the robot. So, I often use it because we can get the students to compare, the real versus the ideal. I'm sorry, real versus the practical, whatever the algorithm has, found out. So, you can comment it out if you want, because we are only going to use odom here. Alright, then, so this one just establishes an object, right? But from C++, you need an instance of the object. So therefore, this VEL MSG, it creates a specific instance, that obeys this particular structure. So VEL MSG is where you're going to enter your numbers. So you can do it automatically. Of course, if you use Rajnikant over there, you have to put Rajnikant here. Otherwise, it'll give you an error. It's going to say, who is this Rajnikant? Okay, now I'm setting the velocity, 0.4 and 0.2. Now remember I told you that the maximum velocity of the Turtlebot 3 is 0.22 meters per second. But you know what's going to happen? Simulations are going to be a little bit slower. It's going to take 5 seconds to cross one of those squares, right? And you're going to die of boredom. So I said, maybe I can run it faster in the simulator. The real robot is a different thing. It's physically constrained by its design. So I said, let me try 0.4. I haven't gone much further than that because an earlier robot I used 2 years ago, it started spinning out of control. Even the simulation robot, they have managed to put that feature into the simulation. This one doesn't seem to have it. But please don't put 500 meters per second and so on, because, you, you, know, you, you can't lose touch with reality. So 0.4 is okay. 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.10, 0.11, 0.12, 0.13, 0.14, 0.15, 0.16, 0.17, 0.18, 0.19, 0.20, 0.21, 0.22, 0.23, 0.24, 0.25, 0.26, 0.27, 0.28, 0.29, 0.30, 0.31, 0.32, 0.33, 0.34, 0.35, 0.36, 0.37, 0.38, 0.39, 0.40, 0.41, 0.42, 0.43, 0.44, 0.45, 0.46, 0.47, 0.48, 0.49, 0.50, 0.51, 0.52, 0.53, 0.54, 0.55, 0.56, 0.57, 0.58, 0.59, 0.60, 0.61, 0.62, 0.63, 0.64, 0.65, 0.66, 0.67, 0.68, 0.69, 0.70, 0.71, 0.72 and rotation rate is 0.2, the radius of the circle will be the ratio of the two. Okay, then I calculate the radius of the circle, velocity by rotational rate. You know, I don't want to put 2 there, right? Because I want to make it general. So I divide velocity by rotation rate, and 2 pi r gives me the circumference. Because remember I said I'm going to stop it after one circumference, so I'm calculating the circumference. And then I calculate the time for the robot to complete a circumference. You'll find out why. My loop is driven by running the robot for this amount of time. You can also run it for this amount of distance. You can say I want to go the circumference, right? But I'm running it based on time. Velocity and time are related, time and distance are related by velocity, right? You can do it either way. But here, there is a need for doing it by time, and I'll tell you why. Now, this pushes the velocity and rotation rate into your message structure. So this is the linear velocity and this is the angular velocity. Now you're going to say, how did he figure out? I'll show you. Once I run it, variables will appear here. And you'll be able to figure out that this is the right place to put it. So, well message, remember, that was what we used here. So it can't be anything. It has to be whatever you use on the variable here, on the left hand side. Dot capital L linear dot x velocity and well message dot angular dot z rotation rate. So now I get the latest frame of data or down. So right now nothing is moving, so it will tell me that it's in the origin, right? But I need to start plotting with that point. So Odom is receive sub Odom. You don't need to do the model state, you can comment it out. Alright, now again, how do I know that the x coordinate of the Odom data is like this, and similarly the y coordinate is this? I'll show you. Once I run it, we'll be able to explore the variable. So this is, I didn't make it up, I had to figure out that this is what it is. Now, you don't have to do this. I'm just putting it in a shorter variable, because otherwise, if you are doing math with this, every time you need the x position, you'll be carrying the whole thing. So this is unnecessary, right? But of course, it costs you extra memory. Nowadays, there's plenty of memory in computers, not like 30 years ago. So it's better to have clarity. Otherwise, each code line will overflow into multiple lines if you're calling the variable this long name. So I believe in pushing it into this. So you can look up what deal does. Deal is a function in MATLAB. So it creates the x number and the y number here. And I say, if you want to see what model state does, you can do it on your own. Okay, now these are my plotting variables. So x is x position, y is y position. Now, I am going to accumulate all the points and then plot it, not plot point by point. You can't do that in MATLAB, right? But anytime you plot on the screen, you slow down a computer. Did you know that? That when you plot, printing is even worse. The traditional printing, you bang it out. Nobody does that anymore. Even a laser printer, if you want to print, it's going to slow you down. The computer is going to say, what is going on here, and take a nap. So, I am accumulating all the points, then plotting. But even when I do that, MATLAB doesn't like this. MATLAB says, so that's why it'll give a warning here. It says this is not a good way because you should pre-allocate the array. So in other words, MATLAB says, if you know there's going to be 250 points, allocate an array, because allocation, see, what I'm going to do is, the next point comes, I'm going to extend the array. I'm going to add it on, make it longer and longer, right? It's going to start with 1 point, 2 points, 3 points. MATLAB says that's a very inefficient operation. So it says pre-allocate the array. If you don't know how many points you're going to get, over-guess. Allocate 1,000 points. You know what I mean? But this is not an efficient method. But I like it for now. I can fix it later. So I'm starting with 1 point and making it a 2-point array, 3-point array. So that's why it's giving me. See, there it is. It says variable appears to change size in every loop iteration. Consider pre-allocation for speed. So nothing here. All comments. How much time do we have? Okay, now, maybe we'll take an initial shot at this. Now, when you're running a loop, it's never a good idea, particularly in robotics, to run it at blinding speed, as fast as the computer. Because typically in robotics, you have multiple tasks to do, right? And if you're wasting your time running this as fast as you can, then it takes away time from other processes. Now think about this. You have a robot which is a mechanical system. Do you think it's a good idea to say V omega, V omega, V omega, V omega? It's not going to be able to respond to your commands fast enough, right? It has inertia. So in robotics, we always run loops at the minimum speed needed to complete that task. So for instance, I use 10 hertz. Self-driving cars, they use 10 times that, 100 hertz. They will not run it at 1000 hertz or 10,000 hertz. Because what happens is, when I run it at 10 hertz, the rest of the time is available for you to do other MATLAB stuff. Now, this is a very simple program. We don't have any other stuff going on. But typically, as you build more and more complicated algorithms, you can take that time and say, do that other process. That's how you're able to maximize the use of the computer in a real-time task. So, because of that, I've got to use something called ROS rate 10. So I'm saying, this will be clear only after you go do the whole thing. So R is equal to ROS rate 10. So 10 stands for 10 hertz, which means that each loop is being visited only once in 100 milliseconds. 10 hertz, 1000 milliseconds, right? 1000 milliseconds, 10 hertz, that gives you 100 milliseconds per loop. So it's only visiting it every 100 milliseconds. That's fine. The turtle bot, nothing is going to happen to the turtle bot over 100 milliseconds. Just calculate the distance it travels. Not much. So you should not be running a mechanical system faster than it can even understand. You're wasting your effort. So I initialize something called RTT to 0. This is the robot travel time. I'm going to monitor. So remember I said we can monitor distance or time? Well, this is why we monitor time, because unfortunately, not unfortunately, that's the way it is. ROS rate is based on time. So I initialize my robot travel time to 0, and then I say, okay, start the counter. So reset R means start the counter, right? I'm ready to run the loop. So while RTT less than TC, do you recognize the variables? TC was the time taken to go around the circumference. RTT is right now 0, right? So it will do the loop, but I'm going to increment RTT. See what I'm doing? The first thing I'm doing in the loop is I am setting RTT to the total elapsed time. That is a function of the rate object. You don't have to know anything about that. You can just blindly follow it. So I'm initially start with 0, then RTT is R period total elapsed time. So the next time also it's not going to trip the loop, right? Because it's only going to be 100 milliseconds more. 100, it's going to keep going till you complete the time taken to do the circumference. So that's the structure of this loop. And the loop ends right here. And I'll tell you just one thing before we go, and then I can come back and refresh your memory, because you don't have time to complete this. At the end of the loop, you burn the remaining time. That means you don't go faster than 100 milliseconds. So if you haven't finished 100 milliseconds, then you don't want to go and do the loop again. That was a traditional program, right? When it finishes the loop, it will start the loop again. Here it's saying, hey, don't. Wait for 100 milliseconds to elapse. That time is available for other processes. MATLAB takes care of it. It will allocate it to other processes. We don't have any in the simple program, but it's a good practice. And then this afternoon, I'll come and finish up with the rest of it. There's not much more, because there's just the plotting and the remaining parts of the loop here. So this is what. Can you just raise the screen? I'll show it to them. I'm going to give you a glimpse of your first exercise. I'll formally write it up this evening, but magically you'll see calligraphy there. My calligraphy, handwriting. Come on. So you see the L there? So what if when I run the program, you're going to see, I think I already ran it. You saw a circle, right? And what if I asked you to make the robot, do this? So how are you going to do that? Now remember, the V and omega dictates that you'll get a circle, right? Remember that? The V and omega fixes a circle. So, can you conceive of this L in terms of small circles? There is no perfect solution. So don't waste your time trying to make the perfect L. If it's approximately this shape, it's okay. So break it up into maybe a circle here, another semicircle, and then more or less a circle with a huge radius, right? Because when you go straight, what is if you consider a straight line, can you consider it as a circle of a certain radius? Isn't a straight line a circle of infinite radius? You can't put infinity because, computer programs don't like infinity. So you'll have to put a large value. So this is almost like a straight. And then you can do a full circle here. And then maybe 2 circles. So it's left to you. Each person is going to be different, right? But so long as it looks approximately as a circle, great. You've done the job. Now, the only thing is, you're going around the circle this way, right? How do you go around a circle clockwise? So V positive, omega negative. So whenever you want to go this way, you make omega negative. And now I think you will have the confidence to do this once you get the basic program working. So I'll see you this afternoon. At 4 o'clock, right? 4. So those expert programmers, they use the structure in itself, and it's very irritating because the expert, object-oriented programming guys, structures, they use the full original name of the variable, and it will be unreadable. Every line of code will be overflowing into the next because they don't want to waste any memory by saving it in a variable with a different name. So I find that unreadable.